Hey guys, this is Coach Brian with part 1 of our 1.3 notes for pre-calculus. In this first part of the 1.3 notes, we're going to be looking at the quadratic and absolute value equations. We will find important features and critical points of both of these functions, and I will, which is what you guys will do, explain to a neighbor how to graph these two functions, quadratic and absolute value. So let's start off talking more about the quadratic function. You probably remember some things about the quadratic function from Algebra 2. The quadratic function is a function that has a highest power of 2. So it's a function that, its first or highest power is a 2. It's got an x squared somewhere in it, or a letter squared. And when we graph the quadratic function, we get the shape of a parabola. So if you don't remember what that is, it's kind of this U shape. And there are two different ways that we can write the quadratic function. We can write it as a standard form, which is probably what you're really used to seeing. So we have our y equals, and then we have our x squared, our x, and then our constant. And sometimes there's a letter in front of those, all right, an A value or a B value. And then another way we can write it is in vertex form. And if you remember, the vertex is like, which we'll also talk about in a little bit, but it's like the turning point of the parabola. So we have this turning point. If we were to graph it, it has some coordinates h and k, and that's where these two letters come in. And so you can see the vertex form here, y equals a times x minus h squared. So whatever is in these parentheses will end up being squared, and then we add k. All right, so there is a letter A in both of these. You can see it right here, and you can see it right here. There's a letter A in both of them. And it is responsible, or it doesn't change, but it's also responsible for two things. One, if A is greater than 0, so pretty much if it's positive, that means your parabola opens up. And what I mean by that is it looks like this. Okay, it opens up. And if A is less than 0, meaning it's negative, then it opens downward like this. Okay, so that's one thing that the A value tells us. The next piece of information that it lets us know, if the absolute value of A is less than 1, so this normally will mean that it's a fraction, then our parabola will be vertically compressed. And that actually means your graph gets wider. The way that I think about it is like if you had your parabola, okay, you had your parabola and you just from above and below just squished it. That's the best way I can think of it. You just squish it down. So what's it gonna do? It's gonna like squeeze out. It's gonna get wider. And then if the absolute value of A is greater than 1, it is going to vertically stretch, which again, it would be like if you grab this point here and this point here and this one was anchored and you just pulled up. And so what's it gonna do? It's gonna get taller and it's gonna get narrower. So it's going to get narrower as you vertically stretch it. So that's the two pieces of information that A gives us. It's a pretty important first little detail when we're dealing with these quadratics. Excuse me. So The vertex form of a quadratic function is right here. F of x equals a times x minus h squared plus k. So we need to like figure out what do all these different things mean. All right, so first let's start with hk. We talked about this just a second ago. Hk is the vertex of the parabola. If you're not sure what that means, it's like the turning point, okay? It's like the turning point of the parabola. So where is that on here? I'll make these match. It's our red point right here. This is our vertex, and it is h comma k. So the h and the k they're an ordered pair. They're still an x and a y, but this specific xy is the turning point of our parabola. Let's go with a different color here for the axis of symmetry. All right, so the axis of symmetry is always a vertical line, so it has an equation of x equals. So for instance, just throwing out a number here, let's say this is right here, this point right here is 1. So this entire dotted line right down the middle would be x equals 1 because it covers every x value of 1. The number is the x value, okay? The number right here is the x value. And that same number, that same x, should match the one that's in the vertex. The h should be what your x equals, okay? All right, so some other features to point out to you. Our 2 points right here. Sorry, I picked a dark color to go over a dark color. These are our roots. And if you remember from Algebra 2, we have a lot of names for these. Another name could be your solutions. And we call them our x-intercepts. And we also call them our zeros. The reason we call them zeros is because when you put their coordinates, they have an x value and the y value is 0. And then lastly, I forgot to label this one, so let me go back to this blue color. This is our axis of symmetry. It divides our parabola in half. All right. So we can have a vertex maximum and a vertex minimum. So when you're thinking about a maximum, all right, especially for a parabola, you should be thinking kind of in a like mountain. Okay, think of a mountain. Where's the maximum height on the mountain? It's up at the peak, right? So it's asking us here, would A be positive or negative? So we're saying that this parabola opens down, and we just said up further up our notes that when it opens down, that means A is negative. And then on the flip side, when we have a minimum, all right, you should be thinking like, okay, this is my lowest point. It's your lowest point. Your minimum is. And if you have a low, that means everything else is above it, which means this guy opens up. And we said earlier, if it opens up, then A is going to be positive. All right, so another example here says to label the equations from widest to narrowest. So if you remember from our earlier note up here, this has to do with the absolute value of A. So the more compression, all right, or compression in general, will come from an absolute value of less than 1. So what we want to do is for all these, we want to find our A value and I'm just gonna underline it here. I'm gonna draw in a 1, a 2, a 1/3, a -4. And then we want to find those numbers' absolute values. So the absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 1/3 is 1/3. And the absolute value of -4 is 4. Remember, absolute value, if you think about it on a number line, it just means how far away from 0 is this number. And so, negatives, or absolute value is always going to be positive. And again, it's just representing the distance from 0. So what we set up here is that the vertical compression, okay, is going to come from a absolute value of a less than 1. Are any of these less than 1? The only one less than 1 is a third, because this one is 1. This one's greater than 1. This one's even greater than 1. And what happens when it's greater than 1? Well, that's a vertical stretch. So actually, the higher the number, the more it's stretched, and it's going to be narrow. So the only one that's actually being compressed is this guy right here. And since it's being compressed, that means it's our widest. And then let's go to the opposite end. What's the highest number? Number 4. That's the one that's being stretched vertically the most. So it's going to be our tallest, skinniest, narrowest. And then we just put the other ones in order. This one's 1-to-1, so it's not actually being stretched or compressed. And this one is being stretched. So there's our order right there, from widest, number 1, to narrowest, number 4. All right. Some more review here of transformation rules. All right, you can see the note right here that transformations must be performed in the order that we're about to show you. It's very similar to order of operations. All right, you have to perform your transformations in a particular order. And so you can see we've got our vertex form here. And we have some different values in here that we can shift, change, stretch, compress, that kind of stuff. So let's start with our H value right here. And I'll write all about H. Let me actually switch over. I'll color code these. So H, which is kind of nice, H is a horizontal. So that's kind of easy to remember. H, horizontal, shift. This is going to move your graph left or right. And it moves it. Sorry, I've got this like correction thing on and it made my arrow ugly. All right. It's going to move it by the H number of units. All right. It's going to shift H units. So if H is 2, it's going to move it 2. If it's 7, it's going to move it 7. Now, the weird thing about this is if it's X minus H, you would normally think, hey, everything negative goes left, everything negative goes down, whatever. This is opposite. If it's H, or if H is negative, it's actually moving to the right. And I can explain that more in class if you have a question about that. But on the flip side, if X plus H is in your equation, that's actually going to shift your graph to the left. And yes, that is backwards from what you would expect. Next, let's look at our A value. I'm going to go quick on this one because we've already talked about A and we've actually already worked some examples with A. So if A is less than 0, which means it's negative, it's going to reflect over or about the x-axis. And that's just a proper math vocabulary way of saying that it opens down. okay? And then if the absolute value of A is less than 1, this is what we just looked at. If it's less than 1, it's going to vertically compress, which means the graph is going to get wider. And if the absolute value of A, sorry, I gotta squeeze this in, is greater than 1, it will vertically stretch, which means it's gonna get taller and narrower. All right, and then lastly, this is the one that's always everyone's favorite because it's the easy to remember one. You've got this K value out here by itself, and that's gonna be your vertical shift. That just means up or down. Vertical shift. It's going to go up or down. And this one's nice because a positive K is up and a negative K is down. So it does exactly what you would expect it to do. A positive brings it up and a negative brings it down. All right. Let's look at some examples of transformations. If at any point in here you're not, you're having some trouble, just refer back to your transformation rules, okay? Just refer back to the transformation rules. And just to scan ahead here, you see we've got a couple of examples, okay, that have similar transformations and things like that. And then we get to the you try it section. So when we get to that you try it section, I'm going to let you do those. All right, I'm not going to go over those on this video. I'm going to do these last two examples with you. All right, so it says graph the function, and we've got a lot of information here. I'm going to color code it according to the colors I used up above. So here's my A value. Here's my H value. See if I can find that same green. There's my K value. So there's three different transformations that are happening here to this quadratic function. And how do I know it's quadratic? Got a power of 2. All right, so while I'm on the green marker, I'll focus on the green. I have a negative K, which means I'm going down K units, so down 3. I've got a positive H. This is the one that works a little different, okay? I've got a positive H, which means I'm actually going left 2. Left 2. And then over here, I'm going to draw a little arrow. I've got a negative A, which means I'm going to open down because I'm reflected about the x-axis. So my parabola is going to look like this. All right, so now let's actually graph it. If you remember, the parent functions start at the origin, and then if you're not sure, you can always like make a little table and put some x's and y's and plug some things in. You can see 0, 0, 1, 1, 2, 2 stuff, or excuse me, I already 2, 4, and so you could graph some of these points just to get a kind of a general shape of what we're doing. Okay, you could get like the general shape, and I'll trace this the best I can. All right, so there's our parent function, but now we need to make all these moves. We need to make all these changes, and we need to do them in the order that is listed above. So the first thing we want to do is a horizontal shift. So we said left 2. So if I shifted left 2, I would move this point 1, 2 to the left. No. iPad's trying to guess what I want it to do. No. All right. Let me see if that helps. It does not. Okay, I'm just gonna do it quick. There is my left 2. And I stayed color-coded up until now, I'm sorry. So the next thing, we're going to look at this A value. And if you remember, we have a negative A. So our parabola is actually going to, right here, our x-axis, it's going to reflect over that, which means everything that's on it will stay on it, but everything that's above it is going to now be below it. 1, 2, 3, 4. 1, 2, 3, 4. So we've actually reflected our parabola now. And then the last thing is a vertical shift, and this graph needs to go down 3. So I'm going to take the origin, or the vertex, I'm going to move it down 1, 2, 3. And then I'm going to take all my points and move them down 1, 2, 3. And I'm going to do that again. 1, 2, 1, 2, 3, 4. So I've got all my new points plotted. I'm going to trace this guy out in green. And so green, the green parabola here, is my final shape, final form, final transformed parabola. And so now we can answer some questions about it. After we've done all these things, first question, what's the vertex? Well, that's our point right here. And if you look from the origin, it's -1, -2, and then from the x, it's -1, 2, 3. So our vertex is -2, -3. And is it a max or a minimum? So here you're thinking mountain or valley, mountain or valley. This is like a mountain, which means a mountain has a peak and it's a maximum. Axis of symmetry is going to be the line that splits it down the middle. And if you remember, the axis of symmetry should be x equals h. So it should be x equals this number right here, -2. Okay, and our graph and our drawing that we just did confirms that it is in fact symmetrical over the line x equals -2. And then how many roots, if any? So you would look and you'd be like, where does it cross? I've got it here in yellow. Where does it cross the x-axis? Where does the green graph cross the x-axis? It doesn't. None. All right, it does not cross the x-axis. So it has no roots. All right. Really quickly to wrap up here, we're going to look at the absolute value function, which if you remember, V for value, this is our V-shaped graph. It's always positive unless you have a negative A value, but in its parent form, it's always going to be positive because the absolute value of every number is positive. So as we're looking at this, it's very, very similar, okay? There's two things that are different about it. One, it's got absolute value bars instead of parentheses, and it doesn't have the exponent of 2, okay? So that is not there. So it's very, very similar, and all of the transformation rules are the same. All of their results are the same. All of the order is the same, okay? So let's jump right into an example. We've got our A value, our H, and our K. So looking at these, the A is positive, which means it's going to open up, all right? The absolute value of A is greater than 1, which means it's going to vertically stretch. It's going to get a little narrower. On our horizontal shifts, we have a -5. Remember, these do the opposite of what you would think, so it's actually going to move to the right 5. And then our K value, it's going to move up 3. So we need to do these in order, right? We need to do these in order. On an absolute value function, our origination point is at the origin. So this is our original point. I'm not gonna draw the entire graph every time. I'm going to move some points. And so the key points here, you got 1, 1, you got 2, 2, you got 3, 3. You can kind of see how it goes. So I'm gonna go ahead and just do 1, 1, I'll do 2, 2, and I'll do 3, 3, and let you just kind of see from there. So we need to move it to the right 5. Let me color code this one since I didn't do a good job of that on the last one. I'll make the original, I'll make the parent yellow. Now I'll match my shifts with their color. So I'm gonna move to the right 5. 1, 2, 3, 4, 5. I'm gonna put my 1, 1, 2, 2, 3, 3. Negative 1, 1, negative 2, 2, negative 3, 3. So you can see we moved it to the right 5. Next, we need to look at our A value. It's going to open up, but we've got this, this vertical stretch happening. So what that means is we're going to get narrower, okay? So just using our original points here for an absolute value function, just to show you, if I plugged in a 0, I get out a 0. If I plugged in a 1, I would normally get out a 1, but now this is my function. It's gonna double the answer. So if I was gonna get a 1, I get a 2. I plugged in a 2, it's going to double it. So instead of 0.11, I've actually got 0.12. And instead of 2, 2, I've actually got 2, 4. And instead of 3, 3, I've actually got 3, 6. So 1, 2, 2, 4, 3, 6. So you can see here the blue graph, which I'll go ahead and trace out. See how it got a little narrower than the red? It got a little narrower. That's a horrible line. So the red is like the original stretch compress, and the blue has been vertically stretched. And then the last thing we're gonna do is we gotta shift it up 3. So we're gonna take our vertex and we're gonna go up 1, 2, 3. And again, we have points 1, 2, 2, 1, 2, 3, 4. And I'll just leave it at that so I don't run out of room on the graph. That still gives me enough to be able to sketch her out there. All right, so that is an introduction to quadratic quadratic functions and formulas, absolute value functions, and the different forms that they can be written in, as well as the transformations that can be done on them and the order of those transformations. So go ahead and do the 2 U-triets. You've got 1 quadratic and 1 absolute value. Ask your teacher if you have any questions about these.